Alright, this is a standard form for a quadratic, and if you take away the leading term, which is the x squared term, if you take this away, now this is a linear term. So a linear term is in the form of bx plus c. But since it is no longer a quadratic now, the coefficients, the variables you are using changes, and instead of using bx plus c, use mx plus b. And as it is a function, you would put y is equal to mx plus b. So this is the equation for a slope, for a linear term. Alright, so let's start off with what these variables mean. Okay, so starting off with the m is the slope. This could also be described as the rise over run. I will explain this shortly. The rise over run, and the b value is the y-intercept. This is simply where the graph crosses between the y-axis, the y-intercept. Alright, so let's start off. I'm gonna cut this off a bit, sorry. Let's start off with a just to say a line right here. Okay, so say we have 2 points on this line. Let's use this line or this point right here, and we have a point right here. The rise over run, we could turn these 2 points into a right angle triangle. So if we just do a dotted line down here, dotted line right here, as you can see right here where this line is, this is a right angle triangle now. Not the best, but it is a right angle triangle. So the rise is right here. This is the rise. As you're going up, it is the rise, and as you go to the left, or in this scenario it's the right, it could go to the left or the right, that is the run. So however many units you go to the right, that is the run. That is the run, and however many units go up, that is the rise. Alright, so more about the rise over run, which explains the slope. This could also be represented by this equation called m, because this is equal to the slope. The slope right here, as I said, is m. M is equal to delta y over delta x. Delta y over delta x. For those who are not familiar with delta means change. And anytime you think of change with your basic arithmetic, you have addition, subtracting, multiplication, and division. Change is represented by subtraction, so you're going to be representing change by subtraction. Alright, so we have delta y over delta x, and this could also be represented by m is equal to the difference of y. So you have two sets of coordinates. So you have two y's, and you have two x's. Alright, so let's say the difference of y's. The difference of y's would be y2 minus y1. You're finding the difference over, and you're dividing it by the difference of x's. So it's going to be x2 over x minus x1. Alright, so in a scenario where you'd use this formula, is when you have 2 points. Two sets of coordinates, x, y, and you can name one xy, and you can name the other one x2 and y2, and you would subtract the coordinates, the y2 over y1 over the x2 over x1, to obtain the m value. Alright, so let's do a question like this. Alright, let's say you have the set of coordinates 3, 4 representing our x1, y1 variables, and you have 7, 9 as the other set of coordinates representing our x2, y2 variables. Something you should know is I put the x1, y1 over here, and the y2, x2 over here. You could switch these, but as long as they maintain throughout this equation that we're going to use right here to find the slope, it will be alright. So you have to maintain the order. So you cannot start off with y2 in one spot and then switch it to y1 in the other spot. So in the beginning, when you start off, you could have these two switched, but as you move throughout the equation, you cannot change it. Alright, let's start off with the equation. So we have y2 over y1 x2 minus x1. This is also represented as delta y delta x, delta y over delta x. So let's move horizontally as I don't have too much space. So y2 minus y1, y2 is 9 minus, and we're going to minus y1, which is 4. I'm going to subtract this by x2, which is 7, minus x1, which is 3. Alright, so now let's move a little to the right. 9 minus 4 is going to give you 5, and 7 minus 3 is going to give you 4. Alright, so as you can see in this equation, the y is equal to mx plus b. The m is simply one variable. It's not m over something. So you could definitely get a slope as a fraction. This simply means that, let's move a little lower, the 5 over 4. Remember, a slope is simply rise over run. So this means that it rises 5 units and it goes to the left or right 4 units. Alright, so say you have a slope of just simply 7. Now you may be wondering, what is the rise or run for this? 7, if you put it in a fractional form, it's 7 over 1. So rise over run. This linear term in a graph is simply just going to look a lot higher. It's going to look a lot higher since it is rising a lot more than it is going to the left or right. Alright, so let's go back here. That's the rise over 1. So it's the 7 is rising 7 units, and the run, it is going to the left or right 1 unit. Alright, that was some background information on MX plus B, which is the linear term. Anytime you are dealing with a quadratic, which is ax squared, let me switch a color real quick, which is ax squared plus bx plus c. This makes it a quadratic, and if this is alone, this makes it a linear. This is a linear term, and this is a quadratic term. I'm just gonna put a Q for quadratic. Alright, yeah, that was some background information on linear terms. I will do another video on how to find the b value of a linear term, which is the y-intercept, as we went through. Alright, thanks for watching.